use absolute motion. Okay, not so much, very limited application on this, but more important is our relative motion analysis. Okay, so we are going to start on a new section. Okay, so the new section is what we call, again, before I go on, in the homework or in the textbook, this is the worst example that you will get. Okay, if you can solve this, there's no other example that's more difficult than this. Okay, difficult, it's not really difficult, but it's just a matter of integration. Okay, integration is just lengthy. Okay, so the next topic that we're going to consider is we are going to look at relative motion. Okay, so we are going to first look at relative motion analysis, and we are currently going to focus on velocity first. Okay, once we are done with velocity, acceleration is really, really straightforward. Okay. Right. So I've posted this on Avenue to Learn. I need this figure. Can you all fish this figure? Okay. So everything will be from this figure over here. Okay, as you can see from this figure, right, what we have is a fixed reference. Okay, our fixed reference is our point O. So we have another point to consider is we also have another point, which is point A. This is our translating reference. Okay, so O at point O, that's our fixed, and point A is our translating. Okay, translating means it is what? Moving in a rectilinear motion only. When I say rectilinear over here, why is it rectilinear? Because y prime and x prime orientation did not change. Okay, there is what? No what? Rotation. Okay. So if we were to look at the position, okay, of point B, what we tend to write is RB is equal to RA. Okay, so RB and RA, what does it mean? Is our disposition. Okay, plus RB from A. So when we write B over A, let me put this here. When we write B over A, okay, is basically position or relative position from point A. Okay. Can you put this relative position of point B from point A? Okay. So anything at the denominator is your what? Reference point. Are we clear? Okay, I repeat again, everything from our relative position is at the denominator. Okay, so if we were to look at displacement, so before I go on, if you look at this figure over here, right, I want you to observe the vector. Okay, RB, right, over A, if you look at the vector, right, is pointing towards where? Can't see the color, Eugene. is going in this direction. Can you see that? Okay. So the displacement d r of point B is equal to d r of point A plus by d r B from point A. So we know over here, this is due to both translation and rotation. Whereas over here, this term over here is only due to what? Translation. And RB from A is due to what? Rotation about point A. So if you were to leave the diagram, okay. So can you all leave this diagram? Okay. So this is exactly what we have written. Okay. So at time when it's t is at this position, when time plus by delta t, now point A and point B has changed its position. So we have DRA and DRB. Okay. And that is the vector form, as you can see. So now I wanted to again highlight, okay, just give a quick example. Okay. If point B is 5 and 2, okay, in terms of position, and over here point A is 7 and 5. Okay. So if we were to just quickly do a short example, B over A, okay, in terms of what? In terms of RB over A, means the reference point is at point where? Point B, am I right? Sorry, the reference point is at point A. So if we look at the reference point at point A, in terms of I, you will have minus 2I, okay? And then in terms of J, you have minus what? Minus 3J. Okay. I know this is obvious, but I want this to be clear. Now, this is because over here, this is because reference is at point A. But you can also write, or later in some other examples that you can see later on, if you write RA from point B, right? So over here now, the second form is the reference point is now at point what? Point B. Okay, so if point B is your reference, then it changes the game, right? It changes now, it becomes 2I plus by what? 3J. For the second example, the reference is at where? Point B. Okay, so you can do both. Okay. Okay. So now if we were to bring with reference to this, okay, to this equation over here. Now, in terms of velocity now, okay, in terms of velocity, we can write out that drb over dt is equal to dra over dt plus by drb from point A over dt. Okay. So this will be equal to velocity at point B is equal to velocity at point A plus by velocity of point B from A. Okay. So this over here is your point of interest. Sorry, B over here is your point of what? Whereas A is your reference point. Okay. So you'll always be at this form where VB is equal to VA plus by VB over A. Just not to get you to be confused, where VB is the velocity at point B. Okay. VA is the velocity at point A. Because it's written in this way, okay, this is our what? Reference point. Okay. And then B from A. So this is the velocity of B with reference of A. Okay. And then we can write the expression over there is VB will be equal to VA plus by omega cross RB from point A, where omega is the angular velocity of the rigid body. Okay. Again, this will only work with what? Rigid body assumption between what? Between 2 points. Okay, it will not work otherwise. Okay, so if you can go back to this diagram over here, okay, I want you to write point A and point B are within a rigid body. Okay, so the radius of the RAB will not change with time. That is fixed. Okay. So let's look at the solution procedure. Okay, this is not really difficult. You only need to later on do your vector multiplication. It's not difficult at all. It's pretty straightforward. So the thing to take note now, okay, I'll write out the solution procedure. Let me get rid of this figure. Okay, we looked at solution procedure. So if you were to fix to this procedure, is first we have to determine the X and Y coordinates first. Okay, and then we have to find VA, VB, omega, and RB from A. Okay, and then after that, we applied it into the velocity equation. We have VB is equal to VA plus by omega cross RB from point A, really straightforward. And then when the solution or when the solution is negative in magnitude, Later, we'll calculate magnitude. It indicates that the direction is opposite. Okay, if it's positive, means the direction is correct. So some of you might wonder, why are we learning this for? Okay. On Thursday, I hope I did put something now, or on Wednesday. Yeah, on Wednesday or Thursday, to analyze what will happen when BC were to do a rotation anti-clockwise about omega and what will happen to the piston. Okay, looks difficult, but it's not. Again, this is one of the worst problem that you can get. Okay, I'll see you guys on Wednesday.